Myself Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss about linear measurements. So let's start our second lecture. For today's lecture, we are going to discuss the first topic, which is of introduction to chain survey. And secondly, we will discuss the operations of chain surveying in detail. So without wasting much time, let's start with our first topic, which is introduction of chain survey. So the first question arises, what is the principle of chain survey, right? So basically, to divide the area into the number of triangles of suitable sides, it is known as the triangulation method. That now you must know, because we have discussed in the chapter 2, that is of surveying, right? In which classification of surveying is there, in which based on method we have discussed that triangulation method and traversing method. This triangulation method is used for linear measurement. So the principle of chain surveying is based on which method? Triangulation method. Now you finding the connection between different chapters, right? Now if the area to be surveyed is triangular in shape, if the area to be surveyed is triangular in shape, and if the lengths and sequences of its three sides are recorded, the plan of the area can be easily drawn. This is the concept or use of this triangulation method, right? Now, the second is the terms related to the chain survey. Now, what are the terms that are mostly used while we talk about the chain survey? So now you can see one figure on the screen in which the stations or the main stations are A, B, C, D, right? Now, different points are also located and different lines are generated. Now, let us understand the terms which is specifically used while we are on field for linear measurement or a chain survey, right? So, the first thing is these survey stations. It means all the points at the beginning or at the end of the chain line are considered to be survey stations, right? Next is the main stations. So here, stations taken along the boundary stations, or we can say they are denoted by a triangular. You can see on figure that at the triangulation shape, we have marked points like A, B, C, D. It means they are our boundary points or our main stations. Inside that, we are going to survey the linear measurement for that particular plot area, right? Next is the subsidiary station. It means the stations which are on the main survey lines or any other survey lines are also known as the subsidiary stations. They are again denoted with the circles. Now you can see on the screen that with circles we have marked S1, S2 and S3, right? Next is the tie stations. It means line joining at the tie stations are known as the tie lines, and they are also denoted with the circles. And here you can see the letters like T1 and T2 are the tie stations. Now we have discussed the terms related to stations, but in this figure you can find the terms like baseline, check line, tie line, right? Main survey line. So what are they? So different types of survey line are also utilized to find its better calculation. Here you can see the main survey line. Main survey line is the line when we join the main station points. Now you know what are our main station points? A, B, C, D. It means here line AB, BC, CD and DA is our main survey line. Second you found on screen is the baseline. Now what is a baseline? So generally baseline is something which is the longest line of our survey. So here you can find the longest line is the line BD. So that is considered to be a baseline which is connecting two main stations, right? Which is very important while we want to divide that area into triangles. So our baseline should be very precise so that the triangulation method gives us the exact or accurate area and volume of that particular triangles, right? Next you can find on screen is the check lines. Now you can see the check line is something which is the apex of the triangular is of main station, and you can see the next point is of the baseline. It means here on screen you can see a line AS2 or CS1 is to be considered as the check lines. Again, these are useful to examine the area which is divided. It means the examine the lower or the smaller areas, right? And last is the tie lines. You can see here the T1 and T2 is the tie line. These tie lines are those lines which connect the tie stations. Again, to further subdivide the triangulations or to examine the smaller areas. So this is all about the terms related with the chain survey. So when we go to the field, this kind of terminologies we have to use, right? So that is the second topic for the introduction of chain survey. And now lastly, we will discuss the selection of survey station in chain survey. So it is very important to select the survey stations. Either it can be main station or subsidiary or tie station, right? So now for that, various points are there that we should keep in our mind. In which the first point is that the stations should be intervisible. It means they should be visible. One station, from one station we can see the another one, so that we can connect the lines, right? Second is the survey lines should be minimum as far as possible, so that the distance is low, the accuracy is high, right? Third is the station should form well conditioned triangles. It means interior angles not less than 30 degree and not more than 120 degree. As we are going to apply triangulation method, that formation of triangle should be in such a way where the angles limit is mentioned to create a well conditioned triangles, right? Fourth one is the station points should be so located that the tie lines, check lines, baseline can be easily formed, right? Fifth one is this station points should be selected within the boundary of the area to be surveyed. It should not be outside of the our main area or the plot area, right? And lastly, the survey lines should be taken through fairly level ground as far as practicable. It means if the level of ground is properly finished or properly leveled, so that calculation of that particular area is quite easy if it is possible, right? Every time it is not possible that we get a fair plain ground, right? But if possible, that we should try to get this kind of conditions. So these are the criteria that one should keep in mind while we go for the selection of survey station in chain survey. So that's all for the introduction of chain survey. Now let's move to the second topic for today's lecture, which is operations of chain surveying. Generally, chain survey is divided into three operations, in which first one is the chaining, second one is the ranging, and lastly the offsetting. These all three terms are very useful and practically applicable when we go to the field, right? So let's discuss first a chaining. So the question is, what is a chaining, or how we can do a chaining on a level ground? For that, we have to follow some operations. It means first we have to fix the stations. Now with using pegs, we are fixing the stations. Then we unfold the chain and then we go for the ranging. Now you know for ranging you need the ranging rods, right? Then you are going to measure the distance using that particular chain, and lastly at the end of the practical you fold the chain, right? So that is the procedure that you followed when you go for the chaining on particular level ground, right? So I can say if I have to go on a level ground, then at that time one thing that I should keep in mind, that my station point A and B, here on screen you can see two examples that shows that if A and B is quite far then the length of chain, then I have to identify or mark the intermediate point. And if my A and B is quite inside, then the main chain line, there is no need for the intermediate points, right? That we will clear in the upcoming topics. So now the second type of chaining is chaining on a sloping ground. As I said, for now we are going to discuss chaining on level ground only. Then later on sometimes we will discuss the chaining on sloping ground. So now that is all about the chaining. The second term or the operation for chain surveying is the ranging. Again, the question is, what is ranging? As I said, Ranging is a process of establishing intermediate points on a straight line between two endpoints, right? Now, if I want to explain you, let's assume this is the ground condition and these are two station points, right? A and B. If I want to range these 2 points, or if I want to check that these 2 points are on same line or not, right? Because generally we measure distance between a straight line, not an inclined line, because we know that a straight line gives the accurate answers, right? So here first I have to identify the midpoint of this chain line, and then I will try to make that A, M and B are in a one line. So that is the basic concept of ranging, right? Now let's discuss different methods of ranging. Again, it is a very important topic. So for different method of ranging, I can say it is divided into two types. First is the direct ranging and second is the indirect ranging or a reciprocal ranging. So here you can see again direct ranging is further divided into two types. First one is the direct ranging with the naked eyes or ranging rod, or second is the direct ranging with a line ranger. It means some instrument. And indirect ranging is again with using a theodolite, right? So let's discuss all these in a detail. In which first one is the direct ranging with naked eyes or ranging rods. As I said, if this is the ground condition, A and B point are there, then I have to mark the middle point through my eyes only. It means I am approximately marking the middle point of this chain line. Then by plotting the ranging rods at the end, I judge through my eyes that point A, M and B should be in one line. That is the concept of direct ranging with a naked eyes. But the primary or the necessity for this kind of ranging is that the end stations are intervisible. If I cannot see B point from A point, then this kind of method is not applicable, right? So for that, the first term is that end stations should be intervisible. Even when intermediate ranging rods are fixed on a straight line by direct observation from the end station, that overall process is known as the direct ranging, right? So this is all about the direct ranging with a naked eyes and ranging rods. Now let's discuss the second type, which is direct ranging by line ranger. So again, as I said, a small instrument is used for establishing intermediate points with two distant signals without necessity of sighting from one of them. It means generally it consists of two right-angled isosceles triangle prism placed one above the other. Here on screen you can see a line is there and station P and Q are there. As I said, a small instrument like this is going to be used where, as I said, that two right-angle isosceles triangular prism placed one above the another, where from I can identify that these 2 points are on line or not. Here it is the top prism and it is the bottom prism that is used to see the readings or the image or the reflection from one ranging rod from the Q and another from the P. When these two are in the same line, then and only then we can say that two reflections are on same line, it is in same straight line, or else we have to just give the instruction to the person who carrying or holding that particular ranging rod that from left or right, they have to adjust it in such a way so that the reflection of both the ranging rod should be in one line into this top and bottom prism, right? So this is the concept where the precision is here, while through eyes the accurate results are not there. So this is the method for line ranger. So that we have discussed under the direct ranging. Now lastly and most importantly, let's go for the indirect ranging or reciprocal ranging. It is also known and asked as a reciprocal ranging many times. So the question is, direct ranging and indirect ranging, what is the difference? So the difference is, direct ranging is possible when two stations are visible, but due to any conditions, if the two end stations are not visible, then that is known as the indirect ranging. So when the end stations are not intervisible due to rising ground between them, we should go for the indirect ranging, as well as when the chain line crosses a valley from which the ranging rod at forward station is not visible, and lastly the distance between two ends is too long, at that time also we have to go for the indirect ranging, right? To understand it better, let's assume this is the ground condition and these are our main station points, station point A and B. Now here you can see a hilly area or a high ground condition is there on field. Now it is not possible to see the next or the end station point B from the station point A. At that time I have to mark or take some indirect support by putting indirect ranging rods like ranging rod M and N in such a way so that I can get connection between point A and B. Now, how I can get that connection? For that, as I said, if I transmit the points on paper like this, A and B, and again I plot the lines for M and N, while the task is that while I am choosing point M for the procedure for indirect ranging, M should be in such a way that I can visualize point A as well as point B, as well as from N points marking or the position, it should be in such a way that I can see point B as well as the next or far end point A. It means I am trying to getting some connectivity, right? So that is the basic concept that we should keep in mind while I am selecting the position of station M and N. Is it clear everyone? Okay. After selecting the position of M and N, what procedure one should do to connect or to check that A and B are in same line or not? For that, first as you can see on screen, I have marked M1 and N1, right? Now, I am trying to see station A from station N. It means from N1, I am trying to join my line to A. It means some intermediate point M2 I am getting on the line of M, right? Now, from that point, I am trying to see point B. It means the concept if you are getting that we are trying to discuss or discover the point, far point from the indirect support. It means if I look from M, then I am going to discover B, not A, because A is nearer to M. And while I am looking for, it means from N to A. Here you can see from M you have to always see point B, and from N the far point A you have to always see. But every time you are getting some intermediate points like M2 and N2, and you have to follow this procedure until you will get this all point in the same line. As you can see, I have get 3 triangles or 3 visions, and then after lastly I have find point A, M, N and B in the same line. So this is the procedure. It is possible that first time you will find it is very complicated, but once you draw by yourself, keeping in mind that M and M should be in such a way that you can connect all the points, and whenever you visualize from M, you are going to visualize the far point, it is point B, and from N you are going to visualize point A. And in this process, you are getting some intermediate points on M and N, which you have taken for indirect ranging. So that is why it is known as the indirect ranging. So this is all about the indirect ranging. Now, let's discuss the last operation, which is offsetting. To understand offsetting, let us assume that this is our station point A and B and some object is there. Suppose this is the object and this is the chain line condition. Now what is offset? So generally, distance are measured from the survey line to the object. Right or left of the survey line are called as the offset. Here you can see only one object, but it can be possible that on the both the side or only one side, any object is there. A permanent object should be taken for taking the offsetting. Now, there are different types of offset, in which first one is the perpendicular offset. So here, if I talk about this home or a house, then you are taking a perpendicular. It means from your chain line, you are taking a 90-degree angle to take the linear measurement, right? So that particular home is known as the object. It means offset, and that distance is known as the offsetting, right? But this is known as the perpendicular offset because you are taking it at 90 degree. But if I am talking the second type, which is oblique offset, that there is no specification for angle. It means it is not at 90 degree. That is known as the oblique offset. So this is all about the types of offset based on the angles. Another thing which is most important, which is chainage. So what is chainage? So chainage is something in which from your main station A to the foot of your object, it means from your oblique offset or perpendicular offset, the total distance on the chain is known as the chainage, right? Now, when I am talking about offset, you are going to measure two things. One is the offsetting distance and second is the chaining distance. Because as you know, we can mark any point only and only when you know the x and y coordinates. So imagine this is the x and y axis, then one is the x axis reading and second is the y axis reading is required to mark one point on a chain line. Now, the importance of offsetting is that when we are going on the field, whatever the permanent objects are in the surrounding, then they are used to mark the exact location of our chain line, because it is very important to make any plan or map that what are the permanent objects are there and how far we are doing our practical or what is the exact location of our plot area. So offsetting plays an important role, right? So this is regarding angles. Again, according to length, it can be divided into two types. One is the long offset and second is the short offset. Long offsets are that where the length is equal to or greater than 15 meter, and short offsets are that where the length is less than 15 meter. Here you can see if I am going to take the short offset, then again I go for the perpendicular offset, and vice versa, the long offset, then I will go for the oblique offset. Why? Because generally when the length is more, I cannot take the exact judgment of 90 degree due to curvature of earth. So at that time, by default, the long offset should be given as or treated as the oblique offset. So it is preferable to take the perpendicular offset at the shorter distance, which is of less than 15 meter. It is again very important topic while we want the precision, right? So this is all about the offsetting. Now let's discuss the instruments which are used for taking the offsets. So basically, first instrument is known as the optical square, second is the Indian optical square, third is the open cross staff, and fourth is the prism square. So let's discuss. First is the optical square. Here on screen you can see station A and B are there, and a tree, it means a offset or a object is there. Now I have to calculate or identify if this object is at 90 degree or not. For that, if I going to use optical square which looks like this, how the procedure is to be. Here you can see the construction of this particular instrument is in such a way that the angles between two mirrors from which we are getting the reflection of any object is 45 degree. And due to that, if I see an object, it means the reflection of object in the eye mirror to the edge and to my eye is in such a way that you can see that the 90 degree angle is created, which means I am seeing a tree which is only visible when it is at 90 degree, right? So that is the concept. But when I go to the field using that particular or holding that instrument, at that time it is not possible that I can see it clearly. It means I am trying to say that it is possible that it is visible in such a way that line P and D is not in same line. It is known as the incorrect offsetting. You can see on figure that how the position of a person, an object and the main station point should be discover the object if it is at 90 degree or not. It means what is the correct offsetting? It means when the point P and B is in the same line, then it is known as the correct offsetting. Then and only then you can say that your object is at 90 degree, right? So this is all about the optical square. So I can justify it in a way of principle that the angles between the incident ray and the reflected ray is twice the angle between the mirror. Now you know what is the angle between the mirror? It is 45 degree as I said earlier, and now you are saying that the angle between the incident and reflector ray is twice. It means how much? 90 degree. So 90 degree, it means you are talking about the perpendicular offset. So here the principle is very simple, that the angle between the incident ray and reflected ray is twice the angle between the mirror, right? So that is the basic principle. It means I am using this kind of instruments only when I have to measure the perpendicular offsets, right? And we are trying to use perpendicular offsets more because it gives us more accuracy, right? So this is all about the optical square. Now let's go for the second type, which is Indian optical square. Now this is something which look like this, and if I talk about in detail, it is something like this. It means it is a brass shaped hollow box of about 5 cm size and about 3 cm deep with a handle about 8 cm long fixed underneath, as you can see in this figure. These are the construction of this kind of instruments. Again, the working principle is again same as the optical square, right? It means M1 and M2 are the two mirrors that are fixed to the inclined sides at 45 degree. It means the object is visible if it is at 90 degree, right? So again, AB and CD are two rectangular openings above the mirror, and the total PQRS is the open face which is to be turned towards the object to which the offset is to be taken, right? So this is all about the Indian optical square. Now let's discuss the next term, open cross staff. Now open cross staff is something which look like this. It means its construction is in such a way that it is considered to be the simplest instrument among all, right? At the same time, it consists of 4 metal arms with vertical slit for sighting through at right angle to each other, right? To set out the angles either 45 degree or 90 degree, the French cross staff is used. If I talk about the French cross staff, it is the only instrument till now we have discussed which also calculate the angle at 45 degree, right? Otherwise, all the instruments are used to calculate angles of 90 degree only. It means the perpendicular offsets only. So this is all about open cross staff. Now let's go to the last, which is a prism square. So generally, you can see an instrument on screen which look like this. Here, the working principle is same as optical square. The only difference is that instead of 2 mirrors, a prism is used. Now the question is, which is better, optical square or prism square? Again, here the precision is more of prism square than the optical square, as the prisms are used, right? So that is all about the instruments used for offsetting. That all we have to use while we want to go for the 90 degree offsets or the perpendicular offsets. So this is all about operations of chain survey, which is chaining, ranging and offsetting. So in today's lecture, we have discussed different topics regarding introduction of chain survey and operation of chain survey. I hope you all understand in detail what are the operations and what are the terminologies that we should utilize or use during the field or the chain survey, right? That's all for today's lecture.